Hawking could not write a single equation. Then I understood why he didn't need to. I made an argument. A careful, precise, mathematical argument. Every physicist in the room followed my equations on the board. Stephen closed his eyes. 30 seconds later, he told me exactly where I was wrong. He could not hold a pen. He could not point at a symbol. He found the flaw in my life's work by seeing it as a shape inside his head. And that was the moment I understood that something had happened to this man's brain that should not be impossible. My name is Roger Penrose. I won the Nobel Prize for the mathematics of black holes. But the man who should have shared that prize was already dead. And what his mind could do, I still cannot explain to anyone. This is that story. I first heard about Stephen Hawking in 1965. I was 33. He was 23. He had been told he was going to die. I had just published a theorem, a proof that collapsing stars must create singularities. These are points where the laws of physics break down entirely. It was the first time anyone had shown that black holes are not just theory. They are inevitable. And then I heard that a dying research student at Cambridge had taken my proof and done something to it that I had not thought of. He turned it backwards. I need you to feel the weight of that. I had spent months staring at my own theorem. It did not occur to me, not once, to reverse the direction of time. It occurred to him. If a singularity must form when a star collapses, then a singularity must have existed when the universe expanded. The Big Bang was not a theory. It was a mathematical certainty. And a 23-year-old who could barely walk had just proved it by looking at my own work and seeing something I was blind to. That was the first time I understood that Stephen's mind did not work the way other minds work. He did not build arguments step by step. He saw the shape of an argument, the geometry of it, and rotated it, as if mathematics were a physical object he could turn in his hands. But what I did not know was that this ability was about to be taken from him. What would replace it would be something far more extraordinary. Stephen had been diagnosed in 1963. He was 21 years old. He had motor neuron disease. The doctors said 2 years. He stopped working. He told me later there was no point. Why finish a PhD for a dead man? 2 things saved him. Jane Wilde agreed to marry him despite the diagnosis. And to marry her, he needed a job. To get a job, he needed a PhD. Love gave him a reason to think. Love. The disease moved slowly. He did not die in 2 years, or 5, or 10. But piece by piece, his body was taken from him. First the legs, then the hands. And here is where I need you to understand something that will matter for the rest of this story. A physicist without hands is like a painter without eyes. We think on paper. We think on blackboards. The equations of general relativity fill entire walls. When you cannot hold a pen, you cannot do physics. That is what everyone believed. Stephen did not stop, and what happened next is the reason you are watching this. As his hands failed, Stephen began to develop a way of thinking that no other physicist has ever possessed. He told me that equations stopped being symbols. They became shapes, curves, surfaces, geometries he could hold in his mind and rotate, stretch, deform, the way you might shape a piece of clay. His friend Kip Thorne at Caltech described it better than anyone. He said Stephen manipulated in his mind images of ribbons, curves, cubes, spheres, and topological images, like a coffee cup deforming into a donut. His flowing mental images gave him insights nobody else could find. Think about what that means. Most physicists need paper the way a sculptor needs stone. Stephen had no stone, so he learned to sculpt in empty space. And here is the part that still haunts me. He did not merely compensate for a limitation. He transcended it. Because when you are forced to see equations as geometry, you see connections that no one writing symbols on a blackboard would ever notice. The symbols hide the shape. Stephen could not see the symbols. so he saw the shape directly. Werner Israel, who worked with both of us, compared it to Mozart composing an entire symphony in his head. But Mozart could move his hands. Mozart could write the notes down. Stephen could not write a single note, and that, impossibly, was his advantage. I need to tell you what he did with that advantage, because what happened next on that night when they helped him into bed is something that I believe no other mind on earth could have done. It was 1970. Stephen's daughter Lucy had just been born. A few days later, as he went through the long, slow, laborious process of getting into bed, a process that took him far longer than it would take you or me, something happened. He saw how to define a black hole as pure geometry, not as a region of collapsed matter, not as a place where gravity is strong, as a mathematical surface with precise properties that he could see in his mind the way you see the shape of a room. From this, he proved that the surface of a black hole can never shrink. It can only grow. There is a one-way door in the universe, and the door only gets bigger. But Stephen was not done. 3 years passed, and then came the discovery that would change everything. In 1973, after meeting the Soviet physicist Yakov Zeldovich in Moscow, Stephen set out to prove that a young physicist named Jacob Bekenstein was wrong. Bekenstein had suggested that black holes contain information, that they have entropy like a gas has heat. Stephen thought this was absurd, so he set out to destroy the idea. He combined two theories that had never been combined before: quantum mechanics, the physics of the very small, and general relativity, the physics of the very large. No one had done this before. I need you to understand, the mathematics required was enormous. Pages and pages of calculations that most physicists would need weeks of blackboard work to complete. Stephen built the calculation in his mind. His ability to write was fading. Each year, his hands obeyed him less. But the visual method his disease had forced him to create was now the most powerful tool in theoretical physics. Where others needed blackboards, Stephen needed only the inside of his own head. When the answer came, it horrified him. Bekenstein was right. Black holes do have entropy. The implications were catastrophic. If a black hole has a temperature, it must radiate energy. If it radiates energy, it must shrink. If it shrinks long enough, it must vanish entirely. Black holes evaporate. The one-way door of the universe, the door that nothing can escape, has a crack in it. Stephen Hawking found that crack using a mind that could barely hold a pen, but could see the shape of the universe itself. He told Dennis Sciama about the discovery on January 4th, 1974. Sciama was his doctoral supervisor, and one of the most important influences on my own career. Sciama told our colleague Martin Rees. Rees said, "Everything is different. Everything has changed." Stephen spent weeks trying to make the result go away. He was not looking for it. He said later that he had merely tripped over it, and he was rather annoyed. But the mathematics would not break. No matter how he attacked it, the answer held. He presented it at a conference at the Rutherford Laboratory in February. The chairman of the session, John Taylor, stood up and said, "Sorry, Stephen, but this is absolute rubbish." Stephen could not stand to respond. He sat in his wheelchair, his speech already beginning to deteriorate, and defended his result from where he sat. But the mathematics was unassailable. It had not been built from symbols on a blackboard. It had been built from the geometry of space-time itself, assembled inside a mind that saw reality in a way no other human being has ever seen it. Sciama called it the most beautiful paper in the history of physics. I need you to see the irony. The most important equation in modern theoretical physics, the one result that every physicist in the world accepts as the bridge between quantum mechanics and gravity, was created by a man who could not write. The equation he could never put on paper with his own hand is now carved in stone on his memorial in Westminster Abbey. I ask myself this question, and I have never been able to answer it. Would Stephen have made that discovery if he had been healthy? If he could have covered blackboards and equations the way the rest of us do? I am not sure he would have. The discovery required seeing the connection between quantum mechanics and gravity, not through algebra, but through geometry, through shapes, through the curvature of space itself. Stephen saw space that way because he had no other choice. His disability did not hold him back. It gave him a tool that none of us had. That is the thing I cannot explain to anyone. It means the greatest discovery in modern physics was not made despite a devastating disease. It was made because of it. I watched this happen for decades. In 1994, Stephen and I held a public debate at the Isaac Newton Institute in Cambridge. It was modeled on the famous debates between Einstein and Bohr. We disagreed about the fundamental nature of reality. I need to tell you what it felt like to argue with him. I described that moment earlier, when he closed his eyes and found the flaw in my argument. But I did not tell you what it felt like to be on the other side of it. I had spent weeks preparing. I had pages of calculations. I had the full machinery of mathematical physics behind me. Stephen sat there, motionless, eyes closed, and in 30 seconds he saw something in my argument that I could not see with all the tools in the world. He was not checking my algebra. He was seeing the shape of my argument. And the shape was wrong. I have spent my entire career drawing diagrams of the universe. Stephen lived inside one. In that moment, I understood something that I had been circling for 30 years. He did not need equations. He never needed equations. Equations were a limitation that the rest of us suffered from. Stephen was free. In 2018, Stephen died. He was 76 years old. The doctors had given him 2 years. He took 55. 2 years after his death, I stood in Stockholm accepting the Nobel Prize for the work we had begun together. The Singularity theorems, the proof that the Big Bang and black holes are inevitable consequences of Einstein's equations. I stood there alone, and I thought about that 23-year-old research student who had taken my proof and turned it backwards. Who had seen something in my own work that I could not see. Who had gone on to do the greatest calculation in the history of physics entirely inside his head, because a disease had taken everything else away from him. The committee said the prize was for black hole formation. In my mind, it was for Stephen, for every idea he built in the dark and handed to the world like a gift none of us had earned. We remember Newton for answers. We remember Hawking for questions, because that is what Stephen did. He asked questions that could not be answered, and he answered questions that no one thought to ask, and he did all of it inside a body that gave him nothing, and a mind that gave him everything. Stephen could not write a single equation. I used to think that was a tragedy. I used to watch him in his wheelchair, head tilted, eyes moving, and I would wonder how he survived, how any physicist could work without the basic tools. A pen, a blackboard, a sheet of paper. I was wrong. The disease took his hands and gave him something in return that no amount of training, no amount of talent, no amount of blackboard space could ever produce. It gave him the ability to see the universe directly, not through equations, not through symbols, through its geometry, through the way space-time curves and bends and breaks. Every physicist I have ever known looks at the universe through a window. Stephen Hawking lived on the other side of the glass. He could not write a single equation, and now I understand why he never needed to. Stephen William Hawking, 1942 to 2018. His equation is carved in stone. The mind that created it remains unexplained.